This machine can read your thoughts out loud. Let's talk about it. In order to speak, you think the words you want to say, and then an electrical signal gets sent from a part of your brain called the motor cortex to the muscles of your mouth and throat. Those muscles then respond, and you speak the words aloud. But sometimes that pathway can get interrupted. People can think the words just fine, but for whatever reason, the muscles can't respond. But if you can measure those brain-to-muscle signals and identify which mouth parts are being told to flex in what order, you can essentially map out what words would come out as a result. It's like lip reading, but without lips. And scientists have created computer-brain interfaces, or CBIs, that can do exactly that. In a study published last week, researchers placed electrodes into the brains of 4 people who had medical conditions that meant that they could think but not speak words. The electrodes measured the signals from the motor cortex and relayed them into a computer, which was able to decode them into speech, recognizing over 125,000 unique words. Now, on the one hand, this is super exciting for those patients, but on the other hand, there's obviously a big risk to privacy here. You don't want all of your thoughts to get said out loud. That's where the difference between imagined and attempted speech comes in. Scientists weren't sure if speaking versus thinking happened along totally different neurological pathways or the same neurological pathway but with the volume turned way down. When you think words, even if you're not intending to say them out loud, the motor cortex still lights up, just not powerfully enough to actually trigger those speech muscles. It's like you're thinking in a whisper that's too quiet for your mouth muscles to overhear and blab out loud.
Okay, pause. So this idea of a threshold mechanism is still just a theory. Brains are really complicated, and it's almost definitely not like always and the only way it works, but this paper provides some really good evidence that it is at least part of the picture.
This means that CBIs might have difficulty distinguishing between inner and outer thoughts. To get around this, researchers used machine learning to train computers to ignore the signals that occurred below the threshold for attempted speech. They also very cleverly programmed in a code word that a participant could think in order to turn the translation software on and off, essentially muting and unmuting the computer at will. Now, there's still a long way to go with this. When participants were asked to respond to more open-ended requests, like think of the lyrics to your favorite song or think of your favorite vacation, they mostly responded in gibberish. And on that note, I want to end by saying that my favorite part of this paper is actually something that's not in it. The authors refused to report the answers that those patients had given to those open-ended questions because they couldn't be sure that they represented the patient's actual thoughts. They didn't want to attribute quotes to the participants that they hadn't actually intended to communicate. In doing so, they did a really good job of protecting not just their participants' privacy, but also their dignity and autonomy. And I just think that's neat.